In example 2, we want to set up the equations for the linear system and solve using substitution. In part A here, we have a concession stand selling two sizes of snack packs. The large snack pack is $5 and the small snack pack is $3. In one day, the concession stand sold 60 snack packs for a total of 220. Our question is, how many small snack packs did they sell? In word problems like this, it's important to identify what's important, what we know, and what we don't know. So we know that a large snack pack is $5. We know that a small one is $3. And we know that they sold 60 snack packs altogether, for a total of 220 bucks. That's what we know. What we don't know, those are going to become our variables. What we don't know is how many of each one we sold. So I'm going to define a variable. I'm going to let L, and it's kind of an italicized weird L. If I wrote a regular L, it would look like a 1. That would confuse the daylights out of everyone, including me. So we're going to let L equal a large snack pack, or I should really write the number of. So we'll write that right here, number of large snack packs. We're going to let S equal the number of, so I'll write that properly over here, small snack packs. Okay? If L and S don't work for you, if your L looks like a 1 and an S looks like a 5, then just choose a different variable. You could easily use A and B or X and Y, but it is important that you assign some meaning to those variables. And as long as you do that, you'll be fine. We want to write some equations now. Let's use this information here. See the dollar signs? See this dollar sign? So we know that the large snack pack is 5. That's a rate. It's 5 for each snack pack or per each snack pack. And then the small one is 3. So if we want the total amount of dollars for the large snack packs, that would be 5L. In other words, if you had 4 large snack packs, you just multiply 5 times 4 and that'd be 20 bucks. We also, though, need to add in the small snack packs, which would be 3S. That has to be equal to 220. So this would be the total for the large snack packs. If you had the total of the small, that would be the entire total. Now we're going to write an equation based on the number of snack packs. So here we wrote an equation based on the dollar amount, and here we're going to use this 60. So we know that L plus S has to be equal to 60. The number of large snack packs plus the number of small ones has to be a total or equal to 60. We're going to try to use substitution with this. So to do that, what we need to do is solve for a variable. It doesn't matter which one you solve for here. You could actually do it here, but it'd be a little more difficult. You'd be dealing with some fractions, I think, perhaps. So let's just subtract L from each side here. I'm going to leave this as 60 minus L. You could also write this as negative L plus 60. Then we're going to go to this other one over here. We're going to take S out and replace it with 60 minus L. So we've got 5L plus 3 times 60 minus L is equal to 220. Move that up a little bit. So we can use the distributive property here. We've got 5L plus 180 minus 3L is equal to 220. 5L minus 3L is 2L. Still have that plus 180. So we'll subtract 180. And 2L will be equal to 40. Divide by 2, and L will be 20. Now we really have to read the directions here, because what we found is a variable, and we've defined the variable to be the number of large snack packs. But the question specifically asks us how many small snack packs did they sell. So this one's really not the answer. It's totally going to help us though. Let's look at this statement. L is 20, so 20 plus S has to be 60. Or if you go back and read, it says the concession stand sold 60 snack packs. So if they sold 20 large ones, they've got to sell 40 of the other ones. Algebraically, you would just subtract 20 here if you're having a tough time with that. 60 minus 20 is 40. So we would write 40 small snack packs as our answer. You absolutely could double check this. I like to use a calculator to do that. So we know that it's $5 for the large ones, and we sold 20 of them. Then we're going to add 3 times 40. So that's $3 for the small ones, and we think we sold 40. And we're going to multiply those, or multiply each one and add them up, and that's 220 bucks. So that does check with this. Also, 20 and 40 is 60, and we can do that mentally in our head. We've got one last one to do here, another word problem, and we're going to try to do the same thing. So let's read this one together. A school is planning a field trip for 142 people, so a total of 142. That's probably going to be important. The trip will use 6 drivers and 2 types of vehicles. Okay. Buses and vans. The bus can seat 51. The van can seat 10. We're going to write and solve a system of equations to find out how many buses and how many vans will be needed. If we look at this last sentence, this actually will tell us exactly what our variables will be. We want to find how many buses and how many vans, and we don't know that right now. So we're going to pick some nice variables here. You could do X and Y or whatever you want, but I think B and V, B as in Bravo and V as in Victor, would make good sense. I like to pick variables that remind me what they stand for, even though we're going to write that out here. So we want to find out how many buses, so we're going to let B equal the number, it's a quantity of buses. And we're going to let V equal the number of vans. All right, we've got our variables. Now it's time to use the information that we've picked out of the entire problem here and see if we can figure this one out. Now, I'm going to save this here in just a second, but I'm going to use this one. So the trip's going to use 6 drivers. Well, you usually don't have 2 drivers for one vehicle. So to me, this statement means that altogether we have 6 different vehicles. Even though doesn't say that explicitly, we can make that conclusion. So we know that B plus V, or the number of buses plus the number of vans, has to be 6. If it's 7, you don't have a driver. And if it's lower than 6, when you got 2 people driving the same car or vehicle rather, and that's just kind of weird. Let's worry about the next part. So let's do this with the people. So now we've got 142 people, and I don't think that includes the drivers here. You could argue that it would, and you'd have a different solution, but I think we're going to say that this is just like the teachers and the kids. We know that a bus can seat 51 passengers, or it's 51 per bus. That's a rate. So if we want to know how many people would be on that bus, or at least how many people would be in the buses altogether, that'd be 51B. If there's one bus, it's just 51. If there's 2 buses, it's 2 times 51. We're going to add that to the number of people who are in the vans, which is 10V. Set that equal to the total number of people. So this is based on the people, and this is based on the vehicles right here. We're going to try to use substitution with this, so I'm going to subtract B here, and we get V is equal to 6 minus B. We're going to take the V out of this one then, and substitute in what V is equal to, which is 6 minus B. We'll have to do a little bit of algebra here, so we've got 10 times 6, which is 60, and 10 times negative B is negative 10B. We'll combine these together, so this 51B and this negative 10B, when you put those together, you get 41B. Move this up a little bit, and let's see here. We'll subtract 60. So we have 41B equal to 82. We'll divide by 41, and we get B to be 2. So we're going to go back to our statement right here, let B equal the number of buses. So this statement here means that the number of buses is 2. We want to figure out the number of vans, and I'm not even going to plug this in at all. I'm just going to read or look at this statement or read this one. Hey, if there's 6 drivers, that means there's 6 vehicles. If there's 2 buses, the difference has to be made up by the number of vans, and that's got to be 4, right? You could plug it in here and subtract 2 and all that. But we know, just reading this question and looking at this algebraic statement right here, that the number of vans has to be 4. Or yes, that's true. So we're gonna write there are 2 buses and 4 vans. We think that's our solution. I always like to check these just to make sure though. So let's, it's pretty self-explanatory here that there are 6, right? We got that. So let's think about the other one. Let's think about the passengers. So there's 51 in each bus. So that's 51 times 2 buses. And there's 10 for each van. So we're going to multiply 10 by 4 here. And that should be the total. And it is. So this one actually does check and does make sense.